In any hydraulic system, the pump inlet is normally charged with oil by a pressure difference between the reservoir and the pump inlet. A pressure difference, or delta P, must be present for flow to occur through any type of conveyor or hydraulic component. For our example, the pressure in the reservoir is assumed to be 14.7 psi-A. To create a pressure difference, it is necessary to create a pressure difference across the pump inlet. This principle is easily shown by the working of a hydraulic jack. On the intake stroke, the piston moves toward the left. This increase in volume creates a partial vacuum in the pumping chamber and a difference in pressure between the reservoir and the pump inlet. Now, atmospheric pressure pushes the oil from the reservoir to the pumping chamber to fill the void. Cavitation is a common problem which occurs in pumps due to excessive inlet vacuum. Very high inlet vacuum may vaporize the hydraulic fluid. These vapor cavities are carried inside the pump to the outlet and collapse with a considerable force when exposed to outlet pressure. This causes severe damage to the internal parts of the pump, and the resulting particles may cause damage to the pump and the downstream components. Cavitation may be indicated by a noise in the pump. Normally, hydraulic oils have a very high vapor pressure and do not vaporize easily. However, there is still a chance of cavitation as the dissolved air in the oil, typically 6 to 10%, is released in vacuum conditions at the pump inlet. This air is also subjected to high pressure at the pump outlet and implodes, causing damage as it is forced back into solution in the oil. The pressure exerted by a column of oil affects the pressure requirements for pumping oil into a hydraulic system. Let's study the effect of the weight of oil on the pump inlet. Here, the oil reservoir is placed above the pump inlet. The level of oil in the reservoir is 10 feet above the pump inlet. As a result, a pressure of 4 psi is developed at the pump inlet. In this case, the pump is said to be charged with a positive inlet pressure. In this instance, the oil reservoir is placed below the pump inlet. The oil level in the reservoir is 10 feet below the pump inlet. Here, a negative pressure, or a vacuum, equivalent to 4 psi, is required to push oil to the pump inlet. The pump must generate a vacuum of 4 psi at the inlet to allow atmospheric pressure to push the oil to the pump inlet. A leak in the pump inlet line can also cause problems in the working of the pump. The problem occurring in this case is called aeration. Air at atmospheric pressure gets pushed inside the inlet line. This air-oil mixture causes a lot of noise inside the pump and can cause a pump to lose its prime. At the outlet, the air is exposed to pressure and is compressed, causing pump damage, very similar to cavitation damage. Air traveling downstream causes erratic valve and actuator operation. Low oil level in the reservoir as well as leaky fittings can also cause aeration.